Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 19 from the practice paper of paper 4. This is the practice paper set 1 for the IGCSE Cambridge 0580. This is for the new syllabus, for which the paper 2 is now non-calculator. This is the paper 4 in which we're allowed to use calculators. However, it's a different format now, and it's only 2 hours. They're like more shorter kind of questions. And this is question 19 from that paper, which one of my students has asked me to answer, so I'm going to do so. So it says the solutions of the equation x squared plus bx plus c equals 0 are -7 plus root 61 over 2 and -7 minus root 61 over 2. Find the value of b and the value of c. Now, there's different ways that we can answer this question. There's quite a few different ways. Probably the simplest way is to just use the quadratic formula, okay, and compare this to the quadratic formula. That's probably the simplest way. So the quadratic formula, you have ax squared plus bx plus c equals 0. Our formula, you have x squared plus bx plus c equals 0. So we know that a equals 1. We know that a equals 1 because that's there, right? So now, we know the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now we know a is equal to 1, so we can just write this as x equals minus b plus or minus the square root of b squared minus 4c over 2. Because why? We know a equals 1. So now what we can do is we can just compare these with this. Okay, we can compare these with this. Basically, what we have here in our answer is basically we have -7 plus or minus the square root of, and we got 61 over 2. That's what we have. That's exactly what we have here. Okay, so we have -7 plus or minus the square root of 61 over 2. So if we compare these, okay, then this must be the same as that. Okay, that must be the same as that. Okay, everything else is the same. These two must be the same. So we can say that minus b must be the same as -7, which means b equals 7. Okay, and we also can say that these two must be the same if we compare them. This must be the same as this. So we can say that in this case, we can say b squared minus 4c is equal to 61. So we know b is 7 now, so 49 minus 4c equals 61. So we can say 49 minus 61 is equal to 4c. So 49 minus 61 is -12. That's equal to 4c. So c is equal to -12 over 4, which equals -3. So we know that a equals 1, b equals 7, and c is now -3. So we can now say, we can just write the values here, basically. B equals 7 and C equals -3. Okay, so very, very simple way of doing it using the quadratic formula. Okay, there's other ways of doing it as well, okay, which are a bit more complicated. Like you could use completing the square, which is what this is from anyway. The quadratic formula is from that. In an exam situation, I would recommend you just use this method here. But there are other methods. We could use the fact that these two are roots of the equation and work backwards from that. That's going to be a bit complicated because of all these square roots. We can use completing the square, okay, which a bit more complicated than this, but it will also work. Okay, and you can use this method. This is by far the easiest method of using. In fact, I'm going to show you the method that involves completing the square as well, just to make some of you realize. So I'll just copy the page again and do the same question. Okay, so now I'm going to show an alternative method of answering this question apart from using the quadratic formula, and that is by completing the square kind of method. So what we know is this is our answer. Okay, this is our answer. So that means x can either be -7 plus or minus the square root of 61 over 2. Okay, so if we work backwards from completing the square, okay, if you think about what you do when you complete the square, before you reach this situation, these two are separate fractions. You have minus 7 over 2, and this is plus or minus root 61 over 2. And before they were separate fractions, this was on that side of the equation. So you had x plus 7 over 2 equals plus or minus the square root of 61 over 2. And before this happened, you took the square root of both sides. So this was x plus 7 over 2 all squared. And this was 61 over 2. 61 over 4, sorry. 61 over 4. Because the square root is only, it's a bit ambiguous there, but the square root is only for the numerator. So let me write that a bit clearly. That's root 61 over 2. So that gives you 61 over 4. Why? Because, you know, before you square rooted this was 61 and this was 4. Okay? And that was plus or minus before. After you square rooted it. Okay, now, so what we can do now is we can expand this bracket. So we have x squared and then plus, remember you multiply these together and double it. So you're going to have 7x over 2 doubled, which is plus 7x. And then you're going to square this. That's going to give you plus 49 over 4 equals 61 over 4. So we subtract 61 over 4 from both sides. X squared plus 7x plus 49 over 4 minus 61 over 4 equals 0. So x squared plus 7x. 49 minus 69 is negative 12. So negative 12 over 4. So you're left with x squared plus 7x minus 3 equals 0. So we can see b is equal to 7 and c is equal to negative 3. So we got the same answer by working backwards from completing the square, right? This is a more satisfying answer because completing the square, using the quadratic formula is just basically being a parrot in a way. The quadratic formula actually comes from completing the square. If you research it, it actually comes from completing the square. That's where it comes from. When you complete the square for ax squared plus bx plus c equals 0, you end up with our quadratic formula, right? So now, as I said, I would, in an exam situation, most probably go with this method. Okay, just use the quadratic formula, which is given to you on page 2 of the exam anyway in the formula sheet, if you forgot it. However, you know, this is more like the kind of like, what's the word? This is more kind of like shows a better understanding. It's like we're doing the reverse of, we're reversing completing the square. Right? Completing the square, you'd normally start from here, okay, and you'd go this way. Okay, you'd work backwards. All right, so this is like the reverse of completing the square. Anyway, so that answers this question, number 19, in 2 different ways. I hope that was clear. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of, I guess this is from quadratic equations, you can found in the playlist over here. You can subscribe to my channel by clicking on this link, and at the top here you'll find a link that tells you how to find the material in my channel easily. Thank you for watching and see you soon.